everyone, I'm sitting here with my half-finished FICS fusion reactor. Well, that's actually not much of a fusion reactor yet, it's a bit of a cage. But just want to show everybody how we're progressing here. So far we've got the power supply in place, we've got part of the forward vacuum in place, we've got the turbo pump and the turbo controller in place, and we've got some vacuum gauges here, but we're not up to a stage yet where we can actually turn the vacuum system on. But I've been working a little bit on the electrical system. So we have a high voltage power supply here. We have a, if we look inside the cage here, I'm not sure if we can see this from here. I have, first of all, we've got a cage here with an interlock system to prevent high voltage power being on when you have the cage open. We have here a 5 mega ohm ballast resistor where the high voltage comes in from the top. And next to it here I have a 50 kilovolt Zener diode. That's an array of 250 smaller Zener diodes. And just for a test here, I've connected the Zener diode up to the high voltage after the ballast resistor. And I have the ground connection from the Zener diode connected to ground via a 1 kilo ohm resistor. I'll bring the camera over here and show how that looks. So as we can see here, the ground connection from the Zener diode goes via this little 1 kilo ohm ceramic resistor to ground over here, and across this resistor here we can measure the current to ground. So the objective here is that we can measure the current going into the system and the current coming out of the system. Now here at the back of the cage I have a National Instruments data acquisition module. It's a USB 6008. It's one of the smaller ones, one of the more economic ones, but it has analog inputs and it's got analog outputs, which is really all I needed to do here. And it's USB powered. But if we look around the side here, if I just move that camera around the side, the problem with USB cables is you can't really extend a very long cable. So I have a USB to Cat5 converter, which will allow me to run up to 30 meters of cable. So that gives me a good extension. So what I have here now is I have the data acquisition module connected live to my laptop here, and we're running a version of LabVIEW here. And I've set up a basic screen with controls in LabVIEW which can control the high voltage, the current limiter, and we'll have a future one here for the vacuum set point and for the gas flow rate. These two are not connected yet. And we have the meters showing the volts, the current in from the power supply and the current out through the Zener diode. And this large one up here is showing the differential current. So in other words, this one minus that one. So if this one swings positive, the FICS fusion reactor will be producing electricity, and if it swings negative, it will be consuming electricity. So it should be pretty straightforward to see. So we have it hooked up at the moment and running. And this one here is currently showing the current through the Zener diode, so we can get a visual on it. So if I set the current limiter to, let's say, 1.5 milliamps and turn up the voltage here to, let's say, 30 kilovolts, we can see here that the volts are running at 30 kilovolts here, but there's virtually no current running through the system, and any current which is running through is causing no differential current at the moment, because obviously it's running straight through the Zener diode. Once we go a little higher and we hit 50 kilovolts pretty much exactly, we can see the current here starts swinging up, and we go a little further, and now you can see that on the graph here the current swung right out, and we're now getting the full 1.5 milliamps running through the output and through the Zener diode. So the Zener diode works as it's supposed to and seems to be handling the current quite nicely. In actual fact, I never had to fill the Xena diode with oil. It seems to be working fine in its dry state. So the system's working. What's yet to be hooked up is the 2 vacuum gauges and the gas flow control. That's going to have to go through a different DAC because it has to be floating at 50 kilovolts, so it needs to be isolated from the main system. What's holding up my project at the moment is the aluminium discs that will form the accelerator tube. They need to be CNC machined, and I had a company working on it, but the company went into liquidation in the meantime, so now I'm looking for another company with a CNC machine that can make these aluminium discs. It needs to be someone with a decent machine because it's 190 millimeters diameter aluminium billet that needs to be machined. So, you know, a fairly large CNC machine, but it's a fairly straightforward job for somebody who has the right equipment. So hopefully find somebody soon.